All right, I'm going to show you how to do a standard limiting reactant problem. So in this problem, it says, what is the theoretical yield of carbon dioxide in grams when 10 grams of octane reacts with 30 grams of oxygen? Now, I've already spent some time balancing this equation. I know that I have 18 hydrogens over here, so I would have needed a 9 in front of that water molecule, but because 9 is an odd number, I knew I had to double this in order to get the correct number of oxygens in this problem, so that it is a whole number. So this is the balanced equation. 2 moles of octane reacts with 25 moles of oxygen to form 16 moles of carbon dioxide and 18 moles of water. Now I'm going to solve this problem. When you're doing a theoretical yield problem and you are given 2 different masses for reactants, you need to do 2 problems to figure out which one makes the least amount of carbon dioxide, because that is your limiting reactant. So I'm going to take my 10 grams of C8H18, and I'm also going to write down my 30 grams of O2. Now, I need to take both of these through the same process in order to get to grams of CO2. And I'm going to do that same thing here. And it's important that you convert these both to the same amount of product, or the same product, otherwise you can't compare them. So I already went through and wrote the molar masses from the periodic table of each of these compounds underneath the respective formulas. So I'm going to take 114.26. 114.26. That's how many grams are in 1 mole of C8H18. And the grams would cancel. I don't want that. I want actually to get to carbon dioxide. So that's where I use my balanced equation and say 2 moles of C8H18 is 16 moles of CO2. And you'll notice now I'm at moles of CO2. I want grams of CO2, so I take my 44.01 grams, and that's how many are in 1 mole of CO2. That cancels as well. I went through and did the math. This gives you 30.8 grams of carbon dioxide. So in a sense, this would actually tell you if the problem was written 10 grams of octane reacting in excess of O2, you would make 30.8 grams. But you don't know if you have an excess of oxygen yet, because you need to figure out, of that 30 grams that you have, how much carbon dioxide would it make. So the first thing you do is you convert grams of oxygen to moles of oxygen. All right? And then you do the same thing. You find your coefficient, 25 moles of O2 in the balanced equation, and you convert to 16 moles of CO2. And the moles cancel. Now you have to use the molar mass again. So 44.01 grams of CO2 for every 1 mole of CO2. And those cancel. When you go through and do that math, you get 26.4 grams of carbon dioxide. So now, that problem, if I would have said you have an excess amount of octane reacting with 30 grams of oxygen, that's how much CO2. And in this case, that's what happens. Because this number here, 26.4, that is my theoretical yield. I can't make any more than 26.4 grams of carbon dioxide because the oxygen runs out. That's what makes this the limiting reactant.